Hello everyone, welcome to another video where we're discussing PYQs of just PYQs of electromagnetism. Okay, so it will be electromagnetism just PYQs. So I hope you have understood the previous lecture. This will be the third lecture in this series, and I hope you have understood the previous ones. Right. So let's write a question. First question: Two uniformly charged, two uniformly charged insulating solid spheres. Insulating solid spheres A and B, both both of radius A, okay, carry total charges plus q and minus q respectively. Okay, the spheres are placed. The spheres are placed touching each other, touching each other, touching each other, as shown in the figure. As shown in the figure. Okay, if the potential at the center of the sphere, if the potential at the center of the sphere, the potential at the center of the sphere A is VA, that at the center of B, that at the center of B is VB, then the distance VA minus VB, then the distance VA minus VB is, then the distance VA minus VB is, okay. Option A, Q by 4 pi epsilon naught A. Option B, minus Q by 2 pi epsilon naught A. Option C, Q by 2 pi epsilon naught A. Option D, minus Q by 4 pi epsilon naught A. Okay, so please try this question. You have 2 minutes to solve this question. We have 3 minutes. Let's try. You solve it. Okay, see, two uniformly charged solid insulating solid pairs A and B. So they are like this: this is A, B. But in the question they're saying they're touching each other. They're placed so that they're touching each other, A and B. Okay. So see, potential due to A will be what? What is the potential due to A? Hmm. Potential at the center of A is VA. Potential center of B is VB. Right. So these are two uniform charge insulating solid spheres. Hmm. Insulating solid sphere. Their distance will be 2A. Right. Distance will be 2A. Now first tell me if this is a insulating solid sphere, what is the potential at the center? Potential at the center is because of A, the potential is what? VQ by 8 by epsilon by A. And because of B, that will be minus Q by pi epsilon naught 2A. Okay. So if you LCM 8 by epsilon naught A with 3Q minus 4, what do you say? Pi epsilon naught, sorry. 4 pi epsilon naught into 2A. So that will be, this is 8 also. So this is 1. So Q by 8 pi epsilon naught A, that is Q by 4 pi epsilon naught. Okay. So this is potential at A. Now, what is potential B? So because of A, that will be minus 3Q by 8 pi epsilon naught A plus Q by what? 4 pi epsilon naught into it. Right. So that will be minus, if you take the LCM 8 pi epsilon naught A, that will minus 3Q plus Q minus 2Q by 8 pi epsilon A, that will be minus Q by 4 pi epsilon A. Okay. So VA minus VA, VB will be what? VA minus VB will be Q by 4 pi epsilon A minus minus plus, right? Q by 4 pi epsilon A, that will be Q by 2 pi epsilon A. Yeah. Yeah. Is it okay? Is it alright? Okay. The next question. So answer is option C. Option number two. Option number two. A parallel plate capacitor is formed by two circular conducting plates of radius a separated by distance d, separated by distance d, where d is very very less than a. It is being slowly charged. It's being slowly charged. It's being slowly charged by current that is nearly constant, nearly constant. At an instant, when the current is at an instant, when the current is I, when the current is I, the magnetic induction between the plates at a distance a by 2 from the center of the plate is from the center of the plate is option A mu naught I by pi a, option B mu naught I by 2 pi a, option C mu naught I by a, option D mu naught I by 4 pi a. Please try this question. Okay. So how to solve it? See, parallel plate capacitor formed by two circular conducting pole plates of radius is very slowly charged by current that is nearly constant. At an instant when the current is I, magnetic induction between the plates. Magnetic induction means actually magnetic field. Okay. So we have to find the induction between the plates at a distance a by 2 from the center of the plate. So the diagram if I draw, it will be something like this. Right. So current going in. Okay. Okay. So at distance r from the center we have to find, isn't it? And then r is what? R is actually a by 2 from the center of plates at a distance a by 2 from the center of the plate. So the center of the plate I have to calculate. So first of all the formula is what? If you remember the formula for this, that is mu naught I r by 2 pi a square. This is the formula. Okay, this is the formula for it. And so if you put just r is equal to a by 2, if you put, just have to put it here. Straight formula. Okay, you just have to remember the formulas. Mu naught I a by 2 divided by 2 pi a square. So a cancelled out. So mu naught I, that is 4 pi a. Simple, straight and simple. Okay. The option mu naught I by 4 pi a is the answer. Just to play some formula based question. Okay. Next question. Question number 3. The X and Z components of a static magnetic field in a region in a region R, Bx is equal to B naught x square minus y square and Bz is equal to 0 respectively. Which of the following solutions which of the following solutions for its y component is consistent with the Maxwell equation, consistent with the Maxwell equations. Okay. Option A, By is equal to B naught xy. By is equal to minus 2 B naught xy. By is equal to minus B naught x square minus y square. Option D, By is equal to B naught 1 by 3 x square x cube minus xy square. These are the options. Please try this question. Okay. So how to solve it? X and Z components of a static magnetic field in a region are this and this. Okay. Which of the following solutions for its Y component is consistent with the Maxwell equations? Okay. So if you see, Bx is equal to what? B naught x square minus y square, right? And Bz is equal to 0. So if you see del dot B is 0, we know del dot B is 0, right? So del Bx by del x plus del By by del y plus del Bz by del z is equal to 0, right? So if you see, del Bx by del x is 2 B naught x, okay, plus this is 0. Okay. No, this is nothing is there. By is not need there. So by we need. This is 0 is equal to 0. So del by del y is equal to minus 2 b naught x, right? So by will be what? Minus 2 b naught xy. Okay. If we take the integration and all. Okay. So that is the answer. Simple. See, minus 2 b naught x. Okay. So simple again. You just have to think. This is one of the Maxwell equations. Okay. So because it's asked which of the following solution for its y component is consistent with the Maxwell equation. So Maxwell equation, one of the Maxwell equation is this. This is the Gauss law of magnetostatics. So del dot B is 0. So del dot B is del Bx by del x plus del By by del y plus del Bz by del z is equal to 0. So from there we can calculate this. Okay. Yeah. Okay. Next question. Question number 3. Question number 4. A hollow metallic sphere, okay, of radius a, which is kept at a potential kept at a potential which is kept at a potential a, so v naught has a charge has a charge q at center. Okay. the potential at a point the potential at a point outside the sphere the potential at a point outside the sphere at a distance r at a distance r from the center is the holometallic sphere of radius a, which is kept at a potential v naught, has a charge q at the center. Potential at a point outside the sphere at a distance r from the center is option A v naught, option B q by 4 pi epsilon naught r plus v naught a by r, option C q by 4 pi epsilon naught r plus v naught a square by r square, option D v naught a by r. Okay, please try this question. Hollow metallic sphere is there, and radius is a, which is kept at a potential v naught, has a charge q at the center. Okay, radius is a, potential v naught, potential at a point outside the sphere at a distance r from it will be how much? Let's try. hollow metallic sphere of radius A, which is kept at a potential V naught, has a charge Q at the center. The potential at a point outside the sphere at a distance r from the center is. Okay, so let me do it. It's a very easy question. So here, charge on the sphere is Q. So for a hollow metallic sphere, the potential on the surface is um, uh, how much? Q naught by Q by 4 pi epsilon naught A because of the radius. But like if there is a distance for a distance r, the potential will be what? Q by 4 pi epsilon naught r, isn't it? R is the distance. So if I can write it, I can write it as Q by 4 pi epsilon naught A, right? 4 pi epsilon naught A into A by R. Isn't it? A will be cancelled at the end. It will be R. So this is how much? This is your V naught. So V naught into A by R. Okay, because V naught is what? V naught is the potential which is kept at a potential. So kept at a potential on the surface. So V naught is Q by pi epsilon naught A into I just this is A cancel same thing. So I just rewrote it in a different form, and this is your V naught A by R. So this is the final potential. If you see the options, V naught A by, okay, that is the answer. That is the answer. I hope you understood this one. Okay. You just write one more question. Number 5. A uniform magnetic field in the positive z direction passes through a circular wire loop of radius 1 centimeter and resistance 1 ohm lying lying in the xy plane lying in the xy plane. Okay, the field strength is reduced the field strength is reduced the field strength is reduced from 10 tesla to 9 tesla in 1 second. Okay, so the charge transferred the charge transferred across any point the charge transferred across any point in the wire is approximately in the wire is approximately dash. Okay, options are 3.1 in 10 to minus 4 coulomb. Option B 3.4 in 10 to the minus 4 coulomb. Option C, 4.2 in 10 to the minus 4 coulomb. Option D, 5.2 in 10 to the minus 4 coulomb. Okay, please try this question. Okay. So how to solve it? Uniform magnetic field in z direction passes through a circular loop wire of radius 1 centimeter and resistance 1 ohm lying in the xy plane. The field strength is reduced from 10 Tesla to 9 Tesla in 1 second. The charge transfer across any point in the wire is approximately. Okay. See, we know E is equal to what? d phi by dt minus d phi by dt, right? Correct. And we know I is equal to what? dq by dt. Okay. And I is also equal to EMF by resistance. So 1 by R of minus d phi by dt. Okay. Minus d phi by dt. So if you see minus d phi by dt, sorry. Okay, now we can do another thing here. If you see um, uh, minus d phi by, okay, 1 by R, I can write it as minus d by dt of B into A, right? B into A. And your area is constant, it comes out. What is changing? Your magnetic field is changing dq by dt, right? dv by dt. So your dq by dt is equal to this much. Dt cancelled. So dq is equal to minus a by r dv, isn't it? Right? And a is what? This is circular loop, right? So circular while loop. So pi r square by r dv. If you take the magnitude, right? Otherwise, let's take it anyway. Minus 3.14. Radius. Radius is how much given in the question? 1 centimeter. That means 10 to the minus 2 meter square divided by resistance is 1 ohm into dB. Okay. Change in magnetic field. That is 10 Tesla to 9 Tesla. 9 minus 10. Okay. 9 minus 10 is the one. So if you see this becomes makes it positive. So 3.14 into 10 to the power minus 4. Okay. This will be the answer. The charge transfer. Alright. I hope you understood. Okay. Okay. Next question. Now, which of the following transformations, which of the following transformations VA to V dash A of the electrostatic potential of the electrostatic potential potential V and vector potential A is a gauge transformation. Is a gauge transformation. Okay. Option A, V dash is equal to V plus AX and A dash is equal to A plus AT K cap. Option B, V dash is equal to V plus AX and A dash is equal to A minus AT K cap. Option C, V dash is equal to V plus AX, A dash is equal to A plus AT I cap. Option D, V dash is equal to V plus AX and A dash is equal to A minus AT I cap. Okay. Which of the following transformation VA to V dash A of the electrostatic potential V, okay, and vector potential A is a gauge transformation? Please try this question. We have done gauge transformations in our lectures. Okay, you can check that also if you are doubtful about this. Let's try this question. Okay, so how to solve? Let me solve this one. So V dash is equal to V minus del lambda by del T. You have to remember that. Okay, okay, and then if you see, um, if you see here, so del lambda by del T is equal to what? You see, del lambda del T is how much? Minus ax. How? Because if you see in every all the options, it is ax plus ax plus ax plus ax plus x. So it's actually like minus del lambda del t is ax, right? In all the cases. So del lambda by del t is how much? Minus ax, right? Del lambda del t is minus x. So lambda is how much? Lambda is minus axt plus c. Okay. Lambda is minus axt plus c. Okay, now. Okay, what do we need? We need a. Okay, we need a. So a is actually what? A is actually a plus what? A plus del phi, del lambda. Okay, so if you see del lambda, if we do del lambda, that will be what? Minus at I cap, because x is there. So this gradient will make this a vector quantity, and x is there, so it will make it I cap. So I will just put it here now. A dash will be a minus at I cap. Okay, that will be the answer. At I cap minus at I cap. Yeah. Okay. Very good. Okay, that will be this for this class, and I hope you understood all the concepts that we discussed in this class. Okay. Yeah. And see you in the next class. Thank you very much.